Hello, ladies and gentlemen. This is Rajesh of CIC. Now I'm going to give a seminar on lasers and holography. Firstly, what is meant by laser? A laser is a device that emits light through a process of optical amplification based on stimulated emission of electromagnetic radiation. The word laser is an acronym for light amplification by stimulated emission of radiation. The first laser was built in 1960 by Meaman. Now coming to the properties, in laser we have amplitude, intensity, direction, angular speed, wavelength and uh, coherent, right? So coming to the amplitude, laser has higher amplitude, and coming to the intensity, laser has high intensity. Coming to the direction, it has single direction. Here angular speed is low and it has single wavelength, and laser light is coherent, and this is proposed by Albert Einstein. Here, as you can see in the diagram, red, green and blue violet are lasers are emitted. Now coming to laser phenomenon. A laser is created when the electrons in atom in special glasses, crystals or glass absorb energy from an electrical current or another laser and become excited. The excited electrons move from a lower energy orbit to higher energy orbit around the atom's nucleus. This is quantum phenomena discovered by Albert Einstein, and in this phenomena we have stimulated absorption, spontaneous emission and stimulative emission. As you can see in the diagram, the first one represents spontaneous emission or decay, and the second one represents stimulated emission, and the third one represents stimulated absorption. Now coming to stimulated absorption. Stimulated absorption is the starting point to achieve laser. It happens when photon of light having energy E2 minus E1 is incident on an atom in the ground state. The atom in the ground state E1 may absorb the photon and jump to a higher energy state, that is E2. This process is called stimulated absorption or inducted absorption. This is called so because the incident photon has stimulated the atom to absorb the energy. As you can see in the diagram, this shows the stimulated absorption laser, where the photon is incident and the electron is excited to the a higher energy level, that is E2. Now coming to spontaneous emission. When an atom is excited into high energy level by absorption of photon, it may after some time spontaneously return to its ground state, right? Or to some intermediate energy level by releasing the energy in form of photon, which carries the energy in some random directions. This process is called spontaneous emission. As you can see in the diagram, this represents the spontaneous emission. Now coming to third one, stimulated emission. Stimulated emission is the process by which an incoming photon of specific frequency can interact with an excited atomic electron, causing it to drop to a lower energy level. The liberated energy transfers to electromagnetic field, creating a new photon with a phase, frequency, polarization and direction of travel that are all identical to the photons of incident wave. This is called stimulated emission. As you can see in the diagram, this represents the stimulated emission. Now coming to Einstein's coefficient relation. Einstein showed the interaction of radiation with matter with the help of three processes called stimulated absorption, spontaneous emission and stimulated emission. Now coming to first one, stimulated absorption. Let R1 be the rate of absorption of light by E1 to E2. This rate of absorption R1 is proportional to the number of atoms N1 per unit volume in the ground state and proportional to the energy density E of the radiations. That is, R1 is directly proportional to N1 into E, right? So if we remove the proportionality constant, R1 is equal to B12 into N1 into E, where B12 is known as Einstein's coefficient of stimulated absorption, and it represents the probability of absorption of radiation. Now coming to second one, spontaneous emission. The rate of R2 of spontaneous emission from E2 to E1 is independent of energy density E of radiation field. R2 is proportional to the number of atoms N2 in the excited state E2. Thus R2 is directly proportional to N2, so R2 becomes A21 into N2, where A21 is known as Einstein's coefficient for spontaneous emission, and it represents the probability of spontaneous emission. Now coming to the third one, stimulated emission. Rate R3 for stimulated emission E2 to E1 is proportional to the energy density E of radiation field and proportional to the number of atoms N2 in the excited state. Thus N3 is directly proportional to N2 into E. If we remove the proportionality constant, R3 is equal to B21 into N2 into E, where B21 is known as Einstein's coefficient for stimulated emission, and it represents the probability for stimulated emission. In steady state, these two emission rates, that is spontaneous and stimulated, must balance the rate of absorption. So R1 is equal to R2 plus R3. If we solve this equation, we will get the answer as A21 by B21 is equal to 8 pi NV3 divided by C3. This is the relation between Einstein's coefficient in lasers. This is the derivation for it, as you can see in this slide. So by comparing, A21 divided by B21 is equal to 8 pi HB3 divided by C3. This is the relation between Einstein's coefficient in laser. Now coming to laser experiments. Laser experiments consist of active medium, that is solid state, liquid state and gaseous state. The next one is pumping source, energy needed to pump either atoms, ions or molecules. Now coming to the third one, optical resonates. There are two types. First one is fully reflective mirror and the second one is partially reflecting mirror. There are two diagrams down, and the first one is a laser beam used for welding, and the second one is a diagram for laser experiment where it contains gain medium, laser pumping energy, high reflector, output reflector and laser beam. Now coming to the first experiment, that is ruby laser experiment and construction and working of it. The first laser operated successfully was ruby laser. This was first demonstrated using ruby crystal and was given by Myman in 1960. It is a solid state laser. Description: ruby is a crystal of aluminium oxide in which some of aluminium ions are replaced by chromium ions. This is done by dropping small amount of chromium oxide in the melt of purified aluminium oxide. These chromium ions give the crystal a pink or red color depending upon the concentration of chromium ions. Laser rods are prepared from a single crystal of pink ruby which contains 0.05% by weight chromium. Aluminium doesn't participate in the laser action, it only acts as a host. Now coming to spontaneous emission. Lifetime of chromium ions is 10 to 6 seconds in higher energy levels, that is E23. After its lifetime, it gets de-excited to low energy level. Chromium ion in energy level E2 and E3 de-excite to metastable state E4. This is also known as non-radiative transition. Now coming to stimulative emission. Lifetime of metastable state is 10 to 3 seconds, that is in E4. Chromium ion is in metastable state is de-excited from E4 energy level to E1 energy level. During de-excitation, coherent photons are emitted. Active medium or active center. Chromium ions act as an active center in ruby crystal, so it is the chromium ion that produces the laser. Pumping source. A helical flash lamp filled with xenon is used as a pumping source. The ruby crystal is placed inside a xenon flash lamp. Thus, optical pumping is used to achieve population inversion in ruby laser. Optical resonator system. The end of ruby crystal are polished, grounded and made flat. The one of its ends is completely silvered while the other one is partially silvered. to get the output. Thus, the two polished ends act as an optical resonator system. Now, coming to the output of ruby laser is 6943 angstroms, and the output power 10 to the power 4 to 10 to the power 6 watts, and it is in the form of pulses. This is the diagram of ruby laser experiment. Here we can see the ruby crystal and flash tube for optical pumping, and the output 6943 angstroms, partially reflecting mirror and totally reflecting mirror. We can see everything as I mentioned before. This Now coming to the advantages of lasers. This is non-destructive testing method (NDT). Ruby laser is used in the formation of tattoos. This is used in holography for the formation of 3D images. This is used in removal of hair on the skin. This is used in eye surgeries. This is used in industrial applications. It is also used in scanning of barcodes. There are a lot of applications for ruby crystal lasers. Now coming to helium neon laser. Helium neon laser consists of quartz tube, helium plus neon in 10:1 ratio, RF generator, electrodes, fully reflecting mirror, partially reflecting mirror. The helium neon laser was the first gas laser to be operated successfully. It was fabricated by Ali Jawan and his co-workers in Bell Telephone Laboratory in the USA in 1961. Now coming to the description, helium neon laser used as a mixture of 10:1 for its active medium. It consists of a long and narrow discharge tube of diameter of about 1 cm and about 80 cm long. The mixture of it at a pressure of about 1 mm of mercury, the partial pressure of helium gas being 5 to 10 times that of neon. Active medium. The gas mixture of helium and neon forms the active medium, and here neon acts as an active center. Now coming to pumping source. Electric discharge method is used for pumping and achieving population inversion. Pumping of helium atoms. When electric discharge is passed through gas mixture of helium and neon, electrons are accelerated down the discharge tube in which mixture of helium and neon is placed. These accelerated electrons collide with helium atoms and excite them to higher energy level. Now coming to optical resonator system. Quartz tube is taken as set of mirrors and form the optical resonator system. Helium excitation, stimulative absorption. Helium atom absorbs energy from electrons, transfer from helium-1 to helium-3. Now coming to neon de-excitation, that is spontaneous emission. The lifetime of neon atom in higher energy excited state is 10 to 6 seconds. After the lifetime, neon atom undergoes de-excitation. Now coming to stimulated emission, lifetime of neon atom in metastable state is 10 to 3 seconds. Mirrors of optical resonators are so designed to show low reflectivity for wavelength. The photons of wavelength emerges through the partially reflected mirror. Now coming to the output, high intensity laser beam is emitted from partially reflecting mirror of wavelength 6328 angstroms, that is red. This is the schematic diagram of helium neon laser, where you can see the cathode, anode, helium neon gas reservoir, and the output and the glass high reflector. This is the diagram of helium neon laser. Now coming to the applications of helium neon laser. Helium neon gas laser is used to measure the distance of sun, moon and stars from the earth. Helium neon gas laser is used to measure velocity of light. Helium neon gas laser is used for formation of spectrum color. Helium neon gas is used to speed up the chemical reactions. Helium neon gas laser is used in holography for formation of 3D pictures. Helium neon gas laser is used in industrial applications of cutting, welding and testing of materials. Helium neon gas laser is used in medicine for all eye surgeries. Helium neon gas laser is used in cosmetics for color improvement of skin. There are a lot of applications for helium neon lasers. Now coming to the holography. Holography is a technique which enables a wavefront to be recorded and later reconstructed. Holography is best known as a method of generating three-dimensional images. The technique to optically store, retrieve, and process information. Preserve the 3D information of a holographed subject. As you can see in the diagram, that is a holography. Means that here we produce a 3D image by storing and retrieving and processing the information. Why do we need hologram? A high resolution three-dimensional recording of an object takes place in hologram. Glasses free 3D display. There is no need for 3D glasses anymore, and there is no need for projection screen anymore. Lifelike images, interactive display. Holographic display technology has the ability to create the illusion of 3D objects in volumetric space by engaging all four visual functions. As you can see in the diagram, that's a hologram. That looks like real for me. Now coming to the differences between conventional and hologram. In conventional, a 2D version of 3D scene is appeared and the photograph lacks depth perception. Film is sensitive to radiant energy and phase relations is lost. Now coming to hologram, it freezes the wavefront of light that carries all visuals information of scene. To view a hologram, wavefront is reconstructed. It provides depth perception. Now coming to the working of hologram. The time variant light field of a scene with all its physical properties is to be recorded and then regenerated. As the working is divided into two phases, one is recording and another one is reconstruction. Now coming to the recording part, basic tools required are a red laser and lenses, beam splitter, mirrors and holographic films. Holograms are recorded in dark environment. As you can see the diagram, these are the required basic tools like beam splitter and the object and mirror, photographic plate and red lasers, lenses, etc. Here the holograms are recorded in dark environment. Now coming to the process, when the two laser beams reach the recording medium, their light waves intersect and interference with each other. It is this interference pattern that is imprinted on the recording medium. As you can see in the first diagram, there is a recording material and the hologram is being recorded and it is reconstructed on the recording material, right? And the second picture, as you can see, that is the interference pattern which is imprinted on the recording medium. Now coming to the reconstruction of holography. In this reconstruction process, the hologram is illuminated by laser beam and this beam is called reconstruction beam. This beam is identical to reference beam used in construction of hologram. The reconstruction beam, after passing through a hologram, produces a real as well as virtual image of the object. The photographic plate is illuminated with original light source used for recording hologram. As you can see in the diagram, that is the virtual image which is formed from the reconstruction of hologram. Now coming to the applications. Educational applications, marketing with 3D holographic display, 3D stimulated display for scientific visualization, military space applications, entertainment displays, telepresence and video conferencing, improved virtual reality and augmented reality. These are the applications of hologram and there are a lot more applications. As you can see in the diagram, that's a human hologram. These are the examples and applications of hologram. Thank you for giving this opportunity. This is Rajesh of CIC signing off.